Hello everyone, in this session we will in detail go through the introduction to the random variable concept. Random variable is not random or it is not a variable. So first of all understand that it is not a random or it is not a variable. In fact it is a function. So what function? So you know that in the probability we have events and the outcome associated with each event. For example, if we consider the sample space capital S and these are the sample points. Sample point or outcome. Now, random variable assigns numbers. It will assign numbers to each and every sample point in the sample space. Definition of random variable. Random variable may be given as the real function of the elements of a sample, and real and random variable associates each outcome in the sample space with a real number. Now let's understand the definition with an example. So toss two coins simultaneously. When we toss two coins simultaneously, we have 4 points in sample space, 2 power 2 4, and they are head head, head tails, tails head and tail tail. Now let the name of the random function or the random variable be x. Define x as number of heads. Now defining the x as number of heads and looking into the sample space, the first point HH has 2 heads in the HH, 1 head in the HT and 1 head in the tails head and 0 heads in the tail tail. Now map all these points on the number line, which is a real line, onto the 0, 1, 2. Depending upon how many heads it has. And this also can be given in the tabular column, where x takes the value of the 2, 1, 1, 0 as per the number of heads in the sample points. Now here we understand how a random variable assigns the value to every point in the sample space. Like the sample point HH is assigned with the value 2. The sample point HT is assigned with the value 1. The sample point TH is assigned with the value 1 and tails with 0. So this is what a random variable is, nothing but assigning a value to every point in the sample space. So the points to be remembered are: a random variable associates a value to every possible outcome. And mathematically, for any omega, now here omega is nothing but the sample point. It may be in the, for example, in the like in the previous example of tossing 2 coins, the omega is nothing but a sample point, so it may be HH, H tail and tails head and tail tail. So for any sample point inside the sample space S, x is a function of sample space on a real number line. Next point, random variable can take either discrete or continuous values. For details, you can refer the classification of discrete and continuous random variables in the next lecture. And coming to the notation, very important, always random variable are represented with capitals, for example X, Y, Z, W, etc. They are capital letters. You can take X, Y, Z, W, whatever. And their numerical values take small x, small y, z, w, so on. And fourth point, we can have several random variables defined on the sample space. So like in the previous example where we have defined x as number of heads, x as a random variable defining number of heads. I can also take one more variable y and define it as number of tails. So that is the reason a sample space may have several random variables. Thank you.